just in case we want a record later. Can you see this here? Or is it too small?
Yes.
It's kind of small. Let's try that. Okay. So yeah, so the big change is getting rid of jars, as I mentioned. And I think it's easiest to just go through a example to show how it's supposed to work, at least right now. The idea is that you have, actually this hello world example is kind of misnamed because it's not minimal. So let me make it minimal. The most minimal version is you don't have any database at all except the main trait. The idea is that you always have some trait that is your database, that is a subtrait of Salsa database. And okay. Anyway, whatever. So you always have a Salsa database trait, and then you have your database struct, and both of them, both the implementation of that trait and the definition of your struct have to be tagged with the Salsa DB macro, and I'll explain in a minute what it does. It doesn't do much, but it does just enough. And then you can also define your own traits, which you can actually kind of see why you might do that. You might do it if you want to add additional functionality like has logger. In that case, you just also tag the trait definition with salsa db. So db goes on the struct, the trait, and the impl of the trait. And then you kind of just do the ret. That's sort of the big thing you have to do, and then everything else is sort of like before. You can say salsa tract, salsa input, and this first parameter of any tract function must be one of these database traits, and that's kind of it in terms of using it. And so it works more or less as before. I guess the other big difference is that the debug impl now fetches the database from some thread local storage. So you don't have to have all that debug stuff anymore. It just kind of works as long as you're in a tract function. And if you're not, there's a way to set it up so that it attach the database. But so that means that your debug output is much easier to deal with. Otherwise, it's not changed. And in particular, I currently kept the tickdb lifetime. I realized it's not essential. We can remove it or not remove it down the line as we wish. It's more about, I guess, if we like it, than it is about ensuring any constraints. So Jack just joined, in theory. So how does it work? Well, the key thing is hi Jack. I was just walking through the stuff I've been doing
Oh, neat.
to make it less annoying. It's sort of the new foundation, I guess I would say. And I was saying that the main thing is you no longer have jars or anything like that. You just have to tag your database struct, trait, and impl. The trait is optional because you can just use the core Salsa database trait. But if you want to have a custom trait for your functions, you tag that with Salsa DB along with the struct and the impl of the database trait. And everything else is sort of dynamically set up for you, so you don't have to do anything else. And I was just about to explain how that works. So the key thing really is in the database, let's see, I guess this is the easiest way to explain it. All the databases have this shared storage, and the shared storage has a map from a type that records which jars are kind of an internal concept, I'll explain in 1 second, which jars have been added to the map so far, to the database so far. So that occurs at most once for any given jar type. And for each jar, it records the first ingredient. So an ingredient is like one trackable thing in the database. Most of the things that you see as a user are a single ingredient, but some of them are composites of one or two ingredients, depending if there's some extra functionality. So for example, a track struct has one main ingredient and then has an ingredient per field, because you can track the changes at a per field granularity. So they need their own IDs. Okay, so yeah, so you have this jar map, and then you have a big vector of ingredients. It's a concurrent vector, which is the main thing is I want to be able to push to it and have it have a stable address as you push. There's a couple crates that do this, but concurrent vec look nice. So let me show you the method, I guess, so you can see the idea. So there's this method add or lookup jar by type. It takes a jar. What is a jar? A jar is a trait that can create a list of ingredients at a particular index. So given the index where they will be added to the vector, to the overall vector, it can create all the ingredients you need and returns a vector of them. And it extends any so that you can get its type ID. So all we do is get the type ID, check if it's not already in the map, then find what will be the next index. Note that the map is locked, so there's no two jars are not added at the same time. Create the ingredients, push them, basically just push them into the vector now. And check that they got pushed at this place we expect. And so that's very simple. What I'm going to show you later is that I'm actually caching this so that it doesn't go through this code every time when it's running, only the very first time that you use any particular thing. So you don't get a mutex lock every time, for example. As long as you have one database, I guess. We can tweak this, but that's how it works now. And once you have the jar added, then you can look up the ingredient. And because this is a concurrent vector, we can actually get, an ampersand that is persistent and valid even as more jars may be added over time. So the address never changes, or at least doesn't change as long as, well, it never changes. In fact, I guess I could return a pin there, but anyway. So that's the core thing. I guess let me walk through one piece of functionality to show you. I also did a big refactoring on the implementation. I think it's much prettier now. So we'll walk through structs. So this is the track struct procedural macro. You can ignore this for 1 second. What I've changed it so that the procedural macros, all of them always generate a call to a macro rules macro for the most part. So the procedural macro just does some like pre-processing and then calls a macro rules macro. And the reason for that is that macro rules is much nicer to work with, assuming your input is in a nice shape. It's not so nice to work with when your input is not in a nice shape, but that's the job of the procedural macro, is to massage things and get it in a nice shape. And also report errors in a prettier way and so forth. So we can actually go look at that macro, and then you can kind of see how it's all put together. So right now there's 3 crates. There's the Salsa macros crate and the Salsa macro rules crate, and then they are both behind a facade with the Salsa crate. So the Salsa crate has its internal details that are private, some public API, and then plumbing, which re-exports all the like private stuff, including these macros. You have to have extra crates in order to have macros that don't show up at the root of the crate. So there's like a funny hierarchy there. So how does the macro rules macro work? Let's see. Right. So it takes all these inputs. Can ignore those for a second, and then you can see basically a tracked struct. The user visible part of it is a non-null pointer to a value, but in here is all the salsa stuff, where we implement different traits and things. And what I wanted to I'm going to scroll down to, oh, you know what? This one is a little bit, I wanted to show you the jar, but I realize now it's not in this file because the jars for track structs are shared. So let me just show you this. No, what is it? Track struct. Yeah, there it is. Right. So a track struct, this is in the Salsa runtime library. Everything is controlled by this configuration. Ignore that. Here it is. This is the jar for a track struct. So it implements the jar trait, which creates a shared storage for the fields, because all the different ingredients associated with the track struct share a view onto a common map where they have the data for a given struct. And then it just iterates through and creates the main struct ingredient along with one for each field and puts it in a big vector. So that's how the jar is implemented. And then one last piece, and then I'll pause to see, because I think I'm jumping all over a lot of files here. But that's how the jar is implemented. And then the last thing I want to show you is how do you actually add it into the database, right? So when you go to make, if we scroll down here, this is actually the new function that's going to get called when you create a new instance of this struct. And so it's going to call this $configuration : ingredient. Configuration is a struct that's local to this little weird block up here. Oh, actually, okay. I hackily just made it equal to this struct because you don't need another struct, but it doesn't matter. The point is, configuration is just this, which has a method. Actually, I'm not sure that's a good idea. I should at least make this private, but anyway. And what does ingredient do? Ingredient creates a static cache, which calls getter create, which in the case where it's not already added, will add this jar into the database. So this static cache is the caching I was talking about. And it just says the first time it runs, it basically just stores a pointer with a unique integer that identifies the database and the actual pointer to the ingredient. So in this way, you only the very first time do you have to actually populate this, and after that, you can just load the raw pointer and cast it. So that's the basic scheme. I ignored one detail so far, which is the way we handle different databases, but I want to stop and see whether it makes sense and if you have questions, or rather what questions you have.
Just gonna say no questions other than it makes sense to me, but others might.
Yeah, the thing that would help clarify how it works for me would be what it looks like when a request is made for a specific like struct field, I guess.
For a specific struct field, like
Yeah,
if you want to read a struct field.
yes.
Yeah, so here's the getter. Well, the struct fields are a little bit funny because in the current implementation, the struct is still represented as a pointer to its underlying data,
Yeah.
which I expect to change because it's not actually sound, I don't think, the way it's implemented now. But and for other reasons, as we discussed last time. But at the moment, this is the getter, and you can see that it basically just grabs its 0th field and calls this method field. So what is 0? 0 is the non-null up here. A non-null pointer to this value type for a given tract struct. The value type is defined here. So for a given tract struct, we'll allocate one of these. It has, it stores the index of the struct itself, along with its unique ID. But most importantly, it has the values of all the fields in a big tuple, along with the revisions when they last changed. And all that stuff is kind of defined by this configuration trait, which says the fields for a given DB lifetime, the fields is a tuple like this, with a tuple of each field type. And the revisions is a fixed length array of length n. I forget exactly why I had to make my own new type wrapper around fixed length arrays. I think because they don't implement indexing or something annoying like that. But this array thing is just a fixed length array. Yeah, I think they didn't implement the deref traits like I wanted them to, so I did it myself. And so when you access, oh right, so when you actually access the field, we're gonna get the pointer and we're gonna call this field method defined on value, which will first compute the ID of the field. So that's requires currently at least an ID has two parts. It has this ingredient index and then the an ID within the ingredient. And the ingredient is the index of the field, which is always computed by adding a certain index to the, like the struct comes first and then the field, so we just add the one to find it. And then it always shares the same ID. So we make this, we report the tract read. This is the runtime code that will add to the current query and say, hey, this read the following field, which had last changed in this revision and had this durability. And then we just cast the actual data to a longer lifetime because we know it's going to stay valid. There's a little bit of a thing here where we actually return a pointer to the entire tuple out of this method, which isn't really meant for users to use directly. So that gives access to all the fields, which is not really what you want. But if you look at the actual code, then we just pull out the field we actually want. And the reason we do that is because we don't know what the type of an individual field is, and there's no way to be generic about that. So it would be annoying. So that's how it works at runtime when you access a field. I think maybe the more representative one is the new, where it actually has to add the jar if it's not already added. But in the case of the field, we already know the jar must be there because otherwise you couldn't have gotten an instance of this struct in the first place. So we don't have to add it again.
Yeah, okay.
Yeah.
That makes sense. Yeah,
and
it's kind of useful to see the simpler one.
Yeah, that makes sense. So this is the default. This is how debug works, but it's not very exciting. But basically, it just grabs this database out of the thread local storage. If there's no database, then it does some fallback behavior. And it cheats and gets access to all the fields without recording any dependency information because I decided that's better than being strict about it. Super annoying otherwise. All right. Any other questions? Or does that all make sense? So the last part of it is tract functions. They're a little bit special. And the reason is that's the place where custom databases actually matter. So I mentioned I want you to be able to define your own database traits. That's so that you can add additional methods and things that are outside of Salsa, but which are usable from inside your tract functions. And so that basically any place that would need to use these extra methods has a little more, or has to deal with the fact that most of the code is oriented around just having a DIN database, a DIN Salsa database, which doesn't have access to those extra methods. So how do we kind of downcast it to saying this isn't just a DIN Salsa database, it's actually a DIN DB that has a has logger and other stuff. And so that was the reason. Dealing with this is exactly why we used to have all that stuff with like jars and all that extra work was so that I could sort of propagate the needed information to where it had to be so that I could do this downcast. But I realized I can do something hackier or more beautiful depending on your point of view. And what happens now is we track no, not upcast, views. Yeah. So within the storage, within the storage for the database, I actually just keep track of all the different downcasts you might have to do. This is kind of some deep, took me a little while to figure out the way to put this all together, but so you have here a list of, for each kind of DIN type you might want to cast to, a function that will convert from the database type, the actual database type, the struct type that is, to this other to this other trait that we don't know the name of. And basically this adds the vtable. That's what it does, like in terms of being actually procedurally. But so then you can do, once you have those, if you have those functions, you can essentially do a cast. Let me find a good one. Try view as. So you can say, given some database type, I can try to cast it to this DB view type. And how would I do that? Well, first I find out the type ID of the database I have, which should be the same as the one I've recorded. Okay. Then I iterate through, and when I find, if I find this caster for the right thing, I can basically grab this coercion function and call it. That's kind of all it does. So yeah, so within the database, I have a list of all the different traits you're using and how to cast to them, basically. Right now, I just made it a vector. So that means when you have to do a downcast, we iterate through this vector comparing type IDs. You could make it, I thought about making it like a perfect hash function or some other thing. There would be ways to make this look up faster, but my expectation is that most of the time there won't be a very large number of database traits, in which case probably iterating through a vector is actually the fastest possible way to do it. But there is some cost there that we have to, that can be optimized. And so then what ends up happening when you define your tracked function, sorry, let me find the right, no. Oh, setup function, there it is. It's almost exactly the same. Let me find the jar, sorry. For a given function, you have a jar, which, or no, it's not the jar. Where is this code? Sorry, try to remember. Somewhere. Oh, okay. Yeah, it doesn't really make a difference. When you're adding the jar, the first time that you add the jar, you have to add the view into the view list. And then, which is what this function does, and I'll explain in a second how. But this basically says, when you add the jar, also add this view. I think this probably could be in a different place. I don't know why I put it here. It doesn't matter. But, and then once you have the view added, why that matters is there's one spot, where is it? Oh, it might be hiding somewhere. Might be in the generic code. But there's a place in the code where when we're about to call your code from the salsa tract function, where we don't know what kind of database we have, we just know we have a salsa database. We need to downcast it into the view that you expect, and we do that downcast. And at that point, we assert, like I think it just unwraps. There should be a cast function, and if there isn't, something went wrong. But so that's how we handle having different traits and doing the downcasting. And that's what this salsa db procedural macro does, actually. So it adds a method to your trait and impl called salsa db. I called it with a Z so it doesn't show up. By the way, Lucas, I have a feature request for Rust Analyzer, but I didn't want it to show up in the list of methods and things, at least not in the front. So I called it salsa db. It would be nice if there was a doc hidden, or if I made something doc hidden or something like that, if it could just not show up in the autocomplete at all. But is there a way to do that?
I think we should be hiding that already, but it might not because it's in the same workspace in your examples here.
Mm-hmm.
There
Okay.
might be a special case there, but I think there's logic for that.
Well, it would be nice in any case if there was a way to override that in this case. But yeah, so it adds a salsa db, or a salsa db method. What does that method do? I don't remember. Yeah, I am marking it doc hidden, so it must be some other thing. Oh, I don't know what this was. Oh, I was thinking about giving it a Unicode name, but I didn't. And what this does is basically, this looks like total magic, like it's just two identity functions. But really what's happening is the input type in this closure is, the input type is the sized type, the database basically, and the output type is the DIN trait path. And so this is doing a coercion. So it's attaching a vtable, and that's the function pointer that we're going to store in the downcast table. So this salsa db basically has to run on some impl where the self type is sized, because that's the one where the compiler, like at monomorphization time, we're going to know the exact struct. And so we'll be able to construct the vtable. And that's why if you go back to hello world, when you put the salsa db here, it's just saying add salsa db like so into the trait. And when you put it on the impl, it's going to add this one. And so in this case, we actually know the type is this database struct, so we can create the coercion. It doesn't have to be like it's perfectly fine, for example, to do this. It's still at monomorphization time, we're still going to know what the type D is. As long as it's a sized self-type, it's not a problem. If you did try to implement this for like a DIN type, it won't work, but don't do that. The only other bit of, it's not really magic, but cleverness perhaps, is that all these methods have the same name. They're all defined. Every database trait has one with the same name, which is totally allowed in Rust. You can have super and subtraits that share the same method name, but if you just use dot notation, you'll get errors, or maybe it won't call the one you want. So I'm not using dot notation. I'm calling it with this fully qualified form so that I know I get the exact one that I actually wanted. Basically saying add the view, this $db becomes the type the type you will downcast to. And this is the type you will downcast from. It's a din type, that doesn't matter because it'll eventually go through the vtable to the real sized implementation. There you have it. That's the thing I've been working on. It's kind of, in some sense, nothing changed except everything changed, and I wound up re-implementing like all the macros and stuff from scratch. The other big thing I changed is the way we're handling parallelism, and that's not really 100% done yet. But that's why almost all the tests are passing except for two. This tracked method doesn't pass because I didn't implement that yet. That's simple. That's just like a little bit of procedural macro stuff. But this one is a little deeper, and it's not that it can't be fixed, but the rewrite will require just a bit more work, and I can explain that. But before I go there, just pause and say, does the downcasting stuff, like what, at least at a high level, make sense? Any questions or concerns?
I did not have the code in front of me as you were talking about this, but it all still made sense as I was listening. So
Okay.
sorry, one of the cats decided to vomit. So
my only concern is that
yes.
it's like, it's not costly, but it's a little bit of work on every function call, at least every cache miss, if you will, every recomputed function. I highly doubt it will ever show up in a profile, but if it did, I guess we could add more caching or cleverness and do some tricks. And if nothing else, you could just not have a lot of database traits. Like in your project, you could probably get down to just one, or maybe even 0 if you don't need any new methods. But it's nice to be able to break up your code into independently compilable crates, which is the whole goal here. So if we really wanted to be, the other option would be having a macro at the final crate, something which kind of goes a little bit back towards the old system, where you can kind of pre-list out the databases that you want to be downcastable to and optimize those cases with some special case code. But anyway, I think I'm quite sure I'm well into the micro optimizing territory here. Root of all evil sort of case. I think it'll be perfectly fine, is my intuition. There's no, it's just O1 cost. All right. Well, so the parallelism stuff, let me explain what I changed. It's a minor change actually, but with some implications. So the old one, in the old case, it used to be that the database had pretty deeply embedded in it this idea of one writer and many concurrent readers. And when you tried to edit one of the inputs, you had to get an and mute, and that would cause cancellation flags to get set out and kill all the other threads and all this other stuff. That logic is all kind of still there, but it's not as deeply embedded in the database anymore. And that is on purpose because I want to get us more towards the Rayon-like parallelism. And so I want to get away from the idea that for a given database struct, it used to be that for any given database struct, you couldn't share it between threads. So you had to kind of make a snapshot and send the snapshot to a thread. You give ownership of that snapshot away. But any given either a database or a snapshot of a database was tied to a specific thread. They weren't sync. They couldn't be shared between threads. That's what I'm trying to change, though I haven't gotten all the way there. So what does it do now? So now the storage for a database, basically this used to be an arc. And the idea was you had many storages, one for each active thread, and each of those storages had a handle to the same shared data. But now I want to get towards the place where there's just one storage, and every thread accesses that storage. So in some sense, the storage is the shared state now. That's not entirely there because this runtime is still thread local. If you can see, it has some ref cells and things. So that's the big thing that still needs to be refactored. But what that means is you can no longer make a snapshot of a database in the same way as you did before. But what you can do, somewhere, I basically made a wrapper. What did I call it? Oh, handle. Probably needs a better name. The idea is you can have a handle around a database. This basically has exactly the same logic, only implemented without quite so much unnecessary complexity. So the handle, you take a database, you put it in a handle, you can send the handle to as many threads as you want, but when you call get mute, it will block until all those other handles go away. So handle is basically this cancellation logic. I'm not actually using this in any of the tests, but I think this would allow you to implement the pattern that you had before. So basically it would be like, instead of, before you used to do database is database new, spawn, thread spawn, and then you would get a snapshot of the database and do stuff with it. And then you would do like some input dot set. And when you did this, it would cause this thread to be canceled. And once the thread was canceled, it would execute. But now you can still kind of do that, except you do it like this. You make a handle, you clone the handle, and then you call db.getMute. And it still works, except now the cancellate, like the logic for this multi-threaded stuff is in the handle and not in the database itself. So what's going to happen is when you call get mute, it's going to check the ref count. The ref count's going to get incremented by db.clone, so it'll know that the handle will know that there's 2 active copies of itself. When you call get mute, it'll set the cancellation flag and wait until the other handle goes away, and then it will call arc get mute and get unique access to the contents. The cancellation flag, of course, triggers panics and things, so that's why this eventually goes away. At least that's the theory. That's it. What's needed is, the only thing that's stopping this sort of vision from working is the fact that currently the database still encodes the thread-specific data, which is essentially the execution stack. So what tracked functions are active. And I think I just gonna move that into thread local storage. I just haven't done it yet. But at that point, once you have that, it becomes possible to encode Rayon-like patterns. The only catch is we have to, if the database, let me think. Well, if we do it with thread local storage, then we can't literally use Rayon because we have to initialize that thread local storage on the worker threads. If we don't do it with thread local storage, I don't know how to do it, but that would be nice. If you didn't have to know what the current function is, or if I found some other way to thread it down, but I don't know how you would do that.
So I have maybe a bad idea, and you should maybe. Well, it's not a bad idea. I think it's an ill-formed idea. I've brought this up, and I think I've chatted with Lucas about this semi-jokingly. It's like, what if, like, Rust Analyzer were async, and it's like, well, what are the blockers for that? And one idea that I've sort of had for a while, and I don't know how reasonable this is, but what if instead of the panic-based cancellation, so it was you had much more of like an async model, and any sort of update, you could cancel computations by dropping a task or a feature instead, potentially. And I know like we're just going through like, hey, here's all this really neat, like here's this really big architectural changes that I'm making, and like that's going to be a lot for us on Author to consider changing to move, well, not consider, but I mean I want to move it over, but like it's going to be a lot to move over, but like I wonder if longer term, if maybe something with async might be the
Yeah,
move here.
I've thought about it. I think it would make sense, but I also think async is still like just a little bit rough around the edges to do this. Once we have DIN support for traits with async functions, though, um, that's probably the big thing is missing. It could be done. There's workarounds. It's just awkward. Yeah, I definitely thought about it. It'd be nice to avoid the panic, but it's not really the hard part of the problem. Also, like I feel like that solves
Yeah,
it
I am
solves
going off
the
on a
easy
tangent here,
parts in
so
some sense. Yeah, or at least it's
but it
you would replace the panic cancellation with a nicer cancellation mechanism, and you could get access to other interesting things. So I'd like to do it, but you still have to thread the local state around somehow. And if anything, it gets just a little bit
task
harder because thread locals and futures play really poorly
task
together.
task locals might be a pretty good option in that case. That's sort of like what decided me to prompt this. So like Tokyo at the very least has a concept of a task local, which is like more fine grained than a thread local, and that might sort of be able to give you the here's the
Yeah,
context of what's calling what. So I
I
mean
don't
that
think
thing is like
they
heap allocated mutex to help, but like it's not going to be contended is the thing.
right, but I don't think um they fundamentally change the nature of the problem. It's just like an alternative. Like it's the same. In other words, I think we can convert from thread locals and panics to task locals and asyncs relatively easily. They're pretty analogous to one another. I don't. It's not. There's not actually a problem at all. Actually, really, it's just work to be done. Like I'm not saying.
Yeah.
In other words, I'm not saying that I don't know how to solve this. I'm only saying that the only thing that if I use thread local state to store the current function or task local in the future, the only thing that means is whatever methods we have that process an array in parallel of work, which is what I would expect to support, we'll have to propagate that task local state
Oh,
to each of the workers. It's not hard. It just means you can't literally use Rayon unless Rayon added a mechanism for thread locals that respected like its own task local, which would actually be a good idea. And maybe we did already. I haven't looked lately. Like I kind of think Rust is missing a mechanism to put it at. If you really want a wide angle, I think there's a concept of task local that is missing from Rust that would apply, like be implemented by Tokyo and Rayon and any other task-like system. But I don't know how to do that right now, so we haven't done it.
yeah, I don't necessarily want to be holding on, blocking on like consensus and stabilization for that. So it
Oh, for
would be
sure.
nice.
Yeah, I think what makes the most sense is um, to stick with the sync model, add some sort of methods that say invoke this closure on everything in this uh, array, basically. Basically add like a variant on the parallel iterator trait. And then uh, once that's done, we can port it over to async later we think that makes sense without too much
Yeah,
difficulty. The hard part
I
of the
think
work
that's.
will be porting Rust Analyzer and the things that use Salsa to async.
I mean, that's that's a bridge to burn at a later point.
Right.
I dropped a link to like Dice, which is like what Bug 2 does. That's sort of explicitly it's sort of inspired by Salsa. It's substantially less nice to use than Salsa, in my view. They have a paper about it that talks about like some of the asymptotic complexities that differ between it and Salsa. That's a small tangent. It's async based. I'm just dropping it because it might be somewhat interesting to look at. Um, I would take a look at the paper. I think there's some interesting asymptotic complexity stuff that I want to get your opinion on. We don't know. I don't know how much of time we have. The other thing I wanted to sort of ask, and to be clear, I really like design. I want to use it ASAP. That's sort of why I've been like bugging you about this, bugging you about this. Um, the other thing I sort of want to
Sweet.
ask about, yeah, there's a bunch of other resources. I'll see if they'll be willing to drop a PDF for it. I don't. I think it'd be fine too. But interning infra. We're talking to LCNR and Michael Goulet the other day, and one of the things that Lucas and you might be able to actually be able to like summarize this better if I stumble over my words. But Ty Kind and within like the solver and a whole bunch of other stuff within Rust-C sort of like do this pointer-based interning type situation, and Salsa does not. And right now we're good. Like the initial Rust-C trade solver integration work, the idea is maybe just stuff it into some thread local storage, um, like the interner, and just rely on that. But I'm just sort of wondering maybe like how feasible or like is it like potentially a really bad idea to like maybe make the interner infra like somewhat pluggable such that like, hey, normally you're going to be assuming this ID thing, but it's like maybe this or but like maybe you'd be able to plug in like Rust-C's interning infra here instead, for lubrification. And as I said, I'm starting realizing it feels like there's a pretty substantial independence mismatch between the two, but wanted to just get your thoughts on that, whether or not that is a reasonable thing to have or not.
Okay, so there's two separate things. One is the interning stuff in Rust-C is an ampersand T basically, which means you can access the data without any database context being passed in, right? It's a pointer, it carries everything it needs to find its data. And from talking to Michael and LCNR, they're, you know, not keen to change that. In other words, they're not keen to rewrite the trait solver so that it threads some context around because it seems annoying. And that particular problem, to some extent, is solved in this newer Salsa because, well, although the helper methods currently take a database, it'd be easy enough to make variants of them that doesn't, but which grab the database from the attached storage. So we can kind of leverage this concept of an attached database to make helper methods that use it to fetch the state. My only concern there is well, I didn't want to do that as the main way that, like, I think that's less good than threading the database around explicitly. Why? I don't know. I guess because it sets you up for panics if you um, don't happen to run in a context that has an attached database, which I don't like. And secondly, because it requires that you do a thread local storage access for every, like, it kind of adds a little runtime cost. And but for the purpose of integrating into these two libraries, I think it will be fine. So
Okay.
we could certainly add that as a stopgap. That's what I'm saying. And then there's another question, which is, could we have the interner be pluggable, and or would it be nice to use Rust-C's mechanism? I think the answer is it actually isn't nice unless you're doing a batch compilation, in which case it is very nice. So I don't know. But like for Rust Analyzer, I think it's not a good fit because there's no hope ever of reclaiming the storage for those intern values. And one of the things I was hoping to get to, which I think we can get to with some more, not there yet, but some, if we, once this refactorings are done, is being able to kind of cap the amount of intern stuff and recycle old slots without any real effort. And Rusty just can't do that. Now, what it gets for not do, by giving up that capability, of course, it gets better performance. I'm curious to know whether Rough would actually want that, because I know you all are interested in serialization and deserialization. I don't know if you planned to run for a long time as well, or
We do, because it's also used in the LSP.
okay. I was thinking that one argument for the TickDB lifetime, actually though, is I think you could make a variant of Salsa, like with a feature gate or just two crates that implement kind of the same duck typeable interface, essentially, that is not meant, basically a variant where you can't modify inputs after they're created. You can only create them once, and maybe you can load the previous state from disk and modify, as you load. Sort of, that's basically Rusty's model, right? Inputs are frozen for any given execution, but change across executions. And I think we could make a variant of Salsa that is specialized for that, which actually uses the real the same interning that Rusty uses. And to do that, you would really need the TickDB lifetime. So it still has some, like, it would be kind of nice to keep it, even if we don't use it because we used IDs, because then we could actually offer two modes and get closer to my eventual hope of actually unifying these two things into one model.
I feel it feels like somewhat related to durabilities. If I'm
Not really. The durability is used to skip the well, okay, it's not unrelated, I suppose, but the durability is
it's a
used
cousin.
to skip the cost of dependency checking. Like, if you set durabilities appropriately, then we can skip walking entire chunks of the dependency tree because we know that nothing with that durability has changed. It sort of applies, that would be equally relevant as an optimization within Rusty. Rusty doesn't take advantage of that. I'm trying to think why that never happened. I think probably just because, I actually don't know why. It might be relevant to Rusty as well. I guess Rusty just spends a lot less time checking dependencies in general because it only has one iteration that it runs. But
One concept that we would find interesting related to this, we haven't fully kind of thought about this, would be if it's possible that some ingredients that you can tell, like this ingredient doesn't really need to be tracked as a dependency, instead track that other thing as dependency. And whenever that other thing changes, then we know that this will change as well. Because we have a lot of very fine-grained dependencies, but we actually know that they will always change whenever the AST changes. So there's no, we don't have them for more fine-grained invalidation. We have them to break cycles at the more fine-grained level. So we actually
I
don't
think
need
that
that
should be
fine-grained
possible.
dependency.
Yeah, I think we should be able to do something like that. I've thought about it before. It's kind of like, the word transparent often comes to my mind, or something like, you don't just want to use it for caching. It would be good to see the example, I guess. So I have to go in a couple minutes, but talking all of this through made me think that what I should probably do is, or that I should probably make the change to the parallel stuff and land this branch, which I think I could do by end of week. But at that point, I think it might be possible to start splitting out and parallelizing up some work, like the main thing I was thinking would be, well, as an example, implementing that feature, Mika, would probably be quite parallelizable. And
I think that the one feature that I think that we would need most immediately is kind of different ways, kind of fixed point, kind of handling fixed point iteration. So that would be a feature that we would be interested in contributing.
Yeah, that's another one that would be very implementable, like split outable. I think what I would probably start working on next is refactoring the ID to implement that page system I was talking about. But that's kind of orthogonal from all this stuff. Like there's sort of how you store the stuff is it needs to change, especially if we want to support speculation and probably for serialization. I'm not sure if there's still serialization work to be done that's orthogonal from that. But everything else is kind of independent from that I can see. Like at that point, extending the dependency tracking system or fixed point is more about the Salsa runtime, which isn't really changing. So we could talk about that next time. Although it occurs to me, yeah, in 2 weeks I'm going to be in Greece and on vacation. So I should cancel that meeting. But if we wanted to meet next week, I could do that. If we wanted to talk about that specific thing, for example, fixed point.
I'd be
I can meet
available
next week.
I'd be available next week as well.
Okay.
While we're on the topic of administration, I sort of wanted to ask, and you might need to go in a moment, but is there any chance of potentially moving like Salsa Zulip to live under the Rustling Zulip, if only because the mobile app is really crummy and it having multiple Zulips there is just a crummy experience, and maybe consolidate some of the discussion?
I'm not opposed. We don't have any like policy around things that are not governed by Rust RFCs living in the rustling Zulip, but we've talked about it from time to time.
Okay.
Yeah, I wish there was a better way to manage that. It's one of the things I don't love about Zulip, but
Yeah, it's fine. The last thing, and I linked to this, and like I said, you need to go, but I linked to a PDF. It's like dice incrementality algorithms in it, and one of the things it talks about, like Salsa, is like it's in their terminology is change subset recomputations, but mountain traversals in lazy dirtying, whereas dice claims to do handle requests with invalidated subset traversals and change subset recomputations. And I forget, and I need to look at exactly how they figure out how they do the dirtying so that it's asymptotically nicer. But given that I was doing some benchmarks on autocomplete, and I saw something like for autocomplete, like the invalidations propagation in the old version of Salsa that Rationalizer uses something like 20% of the entire runtime. I bring that up because maybe there's something to steal from there if
yeah,
it
I'll
doesn't
read
change
it.
the API too much. So
I think it probably would be independent. Okay, I'll take a look. It'd be cool. We should also try to sync with these people,
yeah,
whoever they are. All
I
right.
I sit next to them at work, so
Yeah, that sounds plausible then.
yeah,
All right. Ciao,
cool.
y'all. Thanks for
Take
Bye.
care, y'all. Bye now.
Thank you. See ya.